You know, in this age of AI, we can build things faster than ever before. But here's the thing. Building fast isn't the same as building smart. And that's where architectural thinking comes in. It's that critical skill that really separates fleeting code from lasting, intelligent design. So today, we're going to dig into that mindset shift, the leap from just writing code to actually drawing the blueprint.
Let's kick things off with a classic problem, one that I'm sure many of you in tech have seen play out. You've got this phenomenal coder, right? Someone who's just a rock star, who can solve any problem you throw at them. So what do? You promote them to architect. But instead of leveling up the team, they struggle. It's a classic trap, and it just goes to show how deeply we often misunderstand what it means to be an architect versus a developer.
So what is the real difference here? It's not about being a better coder or writing more complex stuff. Nope. It's a fundamental shift in perspective. It's about thinking on a completely different level, a whole other plane of strategy and vision. And that brings us right to the heart of the matter, what we call the developer to architect problem. Okay, so here's where you can really see the two mindsets side by side. The developer thinks, how do I solve this problem efficiently? And they are absolute masters of that. They take a problem, they divide it, and they conquer it within a given set of rules. But the architect, they're asking a completely different question. They're asking, do we even need this database to begin with? They zoom way out to question the rules themselves. It's this massive leap from how to build something to what we should be building, and more importantly, why. And here's the thing. A brilliant decision made in a vacuum is pretty much useless. A great architect doesn't just pick the right path. They have to be able to sell it. They have to articulate the why behind their choices. They're part storyteller, part negotiator, building that all-important consensus so that everyone, from the engineers on the ground to the execs in the boardroom, gets it and gets on board. So how do architects actually make these huge calls? Well, it all boils down to one core skill: thinking in trade-offs. It's all about that delicate dance between the perfect, ideal solution and the messy, practical realities of any given project. First up, a great architect is always scanning the horizon. They're not trying to reinvent the wheel. They're asking the smart questions. Hey, is there an open source tool that gets us 80% of the way there? Can we just repurpose that thing we built last year? What about that new AI service that just launched? Could that be a game changer for us? It's all about finding leverage. But then you gotta bring every shiny new opportunity back down to earth. You have to face the constraints. What skills does our team actually have right now? What's our real budget, not our wish list budget? And what are the absolute non-negotiable security rules we have to follow? These aren't roadblocks. They're the guardrails that keep your project on a path to success. And this is where the magic really happens. And you know what? It doesn't take some fancy, complicated software. An architect's best friend can be a simple table, just like this one. You lay out your options, and you score them against the things that matter most: compliance, security, whatever. This simple little exercise transforms a messy, subjective debate into a clear, objective analysis. Suddenly, you're not going on gut feelings. You have a data-driven decision you can confidently stand behind. Now, the good news is, you don't have to invent this whole process from scratch. To help structure all this complex thinking, architects lean on established frameworks. Think of them as powerful guides for making sense of all the chaos. So let's take a framework like IEEE 1471. Now, don't worry about the crazy-looking diagram. The core idea is actually super simple. It forces you to think about your system from the viewpoints of all your different stakeholders. The business lead has one view, and it's all about cost. The end user has a totally different view, focused on usability. This framework makes sure you're not just building a system that works, but a system that works for everyone. Then there's the Zachman framework. Honestly, the best way to think about this one is like a giant, super thorough checklist. It's a grid that makes you systematically ask those 6 fundamental questions: what, how, where, who, when, and why, but from a bunch of different perspectives. From the high-level planner down to the person writing the code. It's an incredible way to make sure you have 0 blind spots in your design. And finally, we've got the 4+1 view model. Think of this one exactly like the blueprints for a house. You wouldn't build a house with just one drawing, right? Of course not. You'd have separate plans for the plumbing, the electrical, the foundation. This framework does the exact same thing for software. It gives you different views, like the logical view of what the system does and the physical view of where it's actually going to run. It pieces it all together to create a complete 3-dimensional picture. Okay, which brings us to the elephant in the room. What happens to all of this architectural thinking now in the age of AI? When an algorithm can design a system and spit out the code, where does that leave the architect? And look, it's a totally fair question. If a large language model can spin up an entire application from a single sentence, is the architect obsolete? Well, the answer is a huge definitive no. In fact, their role is becoming more critical than ever. See, instead of making the architect obsolete, AI actually puts their job on steroids. An LLM might generate 10 different technical solutions in the time it takes you to sip your coffee. This creates what we can call an option explosion. So the architect's job isn't so much about designing one solution from scratch anymore. It's about becoming an expert curator, someone who can sift through that sea of AI-generated possibilities and pick the single best one. Here's the catch with AI, though. It's brilliant at solving the exact problem you give it. But what if you're asking the wrong question? That's where the architect comes in. They provide that strategic vision. Their job is to step back and make sure the team isn't just efficiently building a fix for a superficial issue, but is actually tackling the real, underlying business challenge. AI can write code at a speed that is just blinding. But speed without a plan is just a fast track to chaos. Without that architectural oversight, you risk building a Frankenstein's monster, a jumbled mess of mismatched parts that's impossible to maintain. The architect provides the governance, that master blueprint, to make sure all those AI-generated pieces come together to form a coherent, sustainable whole. And at the end of the day, AI is a tool, a ridiculously powerful one for sure. But it doesn't get context. It doesn't understand things like enterprise-grade security or long-term scalability or the really tricky ethical implications of its own design. The architect is that essential human in the loop, that final quality check that ensures our AI-driven systems are not just functional, but also robust, responsible, and reliable. So what's the big takeaway here? In a world flooded with infinite AI-generated options, architectural thinking is your compass. It's the tool you use to navigate all that noise. The most important question is no longer, can we build it? The real question is, of the 100 ways AI can build it, how will you choose the right one? Answering that, well, that's the whole game now.